Okay, so good morning everyone. Last class we discussed about the particle nature, and last class we discussed about the formulas of energy of a photon, that is E is equal to h nu or E is equal to hc by lambda, and we discussed about number of photons, means number of photons emitted will be either energy divided by hc by lambda or power divided by hc by lambda. And in that respect, I have given you 3 sums to solve. So today we will do particle nature ka next part. Today we will do particle nature ka next part, which is called photoelectric effect. Now photoelectric effect is very common to you people, you know. Suppose this is a metal surface. Some frequency of light is falling on it. And as some frequency is falling, then electrons are ejecting out of the surface of the metal. This is called photoelectric effect. So if I define it, means the effect in which metals eject out of the surface of metal, electrons eject out of the surface of metal when some light falls on it is called photoelectric effect. But my question is, will all frequency falls on the light and on the metal, and frequency means metal electrons will eject? Is it necessary? No, it is not necessary. Now suppose you are giving new frequency you are giving. For example, you are giving 2 Hertz, not going, electrons is not ejecting, 3 Hertz, not ejecting, 4 Hertz, not ejecting. You are increasing slowly. Now you see that when you supply 10 Hertz, first electron moves out. When you give 10 Hertz, first electron moves out. Which means 10 Hertz is the minimum frequency at which the electron should eject. मतलब 10 Hertz देना ही पड़ेगा. 1 दिया, 2 दिया, 3 दिया, 4 दिया, 5 दिया, इलेक्ट्रॉन नहीं जा रहा है. 10. 10 Hertz you give, the electron move up. So that 10 Hertz is called nu naught. Nu naught means called threshold frequency. So threshold frequency means minimum frequency at which an electron ejects out. Nu naught means minimum frequency at which an electron ejects out. मतलब पहले nu naught you have to give. So nu naught is 10. After that you give 11, 12, 20, 50, 100. Those are new. Those will be new. So nu naught is the minimum frequency you have to give. After that you are giving nu. So what is nu? Nu means incident frequency after nu naught. So whatever frequency you give after nu naught, that is nu. Which means nu will be greater than nu naught. Which means nu will be greater than nu naught. Got my point? So nu naught is the minimum frequency at which the electron ejects out. उसके बाद तुम जितना देते रहेगा वो सब nu है. So energy related with nu is E is equal to h nu. बाद वाला, मतलब nu naught के बाद वाला. How much energy you give? That is h nu. And energy related with nu naught. Nu naught के साथ जो एनर्जी है उसको हम लोग बोलता है वर्क फंक्शन. फॉर्मूला इज h nu naught. ऐसे जैसे न्यू होने से एनर्जी h nu, वैसे न्यू नॉट होने से एनर्जी h nu naught, बट उसको हम लोग बोलता है वर्क फंक्शन. So when the electron ejects out, it has some velocity. So if it has some velocity, then this electron will have some kinetic energy. Understood? इसका मतलब h nu naught is the initial energy, work function. उसके बाद तुम E दे रहे हैं, E. So once you give h nu naught, then the electron ejects out. So kinetic energy होगा. Which means we have 3 energies: E, work function W naught, and kinetic energy. So with these 3, Einstein gave an equation. Einstein gave an equation which is called Einstein's photoelectric equation. So Einstein said that the total energy which you are giving is equal to the sum of the work function the sum of the work function and kinetic energy. So this is Einstein's photoelectric equation. E is equal to total energy is equal to work function plus kinetic energy, which means E is h nu, work function is h nu naught plus kinetic energy. This implies kinetic energy is equal to h nu minus h nu naught, which means now kinetic energy means half mv square, where m is mass of electron and velocity is v is velocity of electron. So half mv square is equal to h nu minus nu naught. So these are the two equations of Einstein's photoelectric equation. Energy is equal to work function plus kinetic energy. और वर्क फंक्शन का फॉर्मूला क्या है? h nu naught. What is nu naught? Nu naught is threshold frequency. So similarly, here one more you will get. If nu naught is threshold frequency, then nu naught is equal to c by lambda naught, because nu is equal to c by lambda. So nu naught is equal to c by lambda naught. तो lambda naught हो जाएगा threshold wavelength. So students, this is today's topic, on which I will give you some numericals. So you should carefully see that E means h nu, W naught means h into nu naught. So W naught is work function, means this whole is work function. This is threshold frequency, this is h plus kinetic energy. Now kinetic energy is half mv square, half into mass into velocity का square. So अगर तुम बिठाएगा तो half mv square means h into nu minus nu naught. Sometimes velocity is not given. You can still find out the kinetic energy by this formula, h nu minus h nu naught. Now h you know, Planck's constant is 6.63 into 10 to the power minus 34 joule second. So based on only this equation, you will do your sums. Once again I repeat, E, h nu, W naught, h nu naught, Ke, kinetic energy. W naught मतलब h nu naught, nu naught again मतलब c by lambda naught. Lambda naught is threshold wavelength, threshold frequency, work function, kinetic energy. So with this you have to solve the numericals. I will be sending you the notes as well as I will be sending you the questions for doing the numericals. Till then, thank you very much. Happy learning, and in case of any doubt, please reach out to me. So this we are doing development to Bohr's model. Bohr's model will not come in PT1. In PT1 khali development आएगा. So this is we are over with particle nature. Next class we will start spectrum, absorption spectrum and emission spectrum. Next class, okay? So till then you do this much. Thank you very much. Stay safe and happy learning. And be safe, because Guwahati is nowadays becoming very difficult to stay. Guwahati is in a very dangerous situation. So please be aware and wash your hands regularly, okay? Thank you very much.